Good morning, dear students. Welcome to math class. Today we will discuss about matrix and its determinant. In previous class, we discussed about matrix and its additions, subtraction, multiplication, and what is transpose matrix, what is adjoint matrix, what is minor, we discussed. And here determinant is nearer to minor. For 2 by 2, the minor is nothing but a determinant. For 3 by 3, we have some procedure. So here we will learn the what is determinant and how to find the determinant. So this is chapter 3rd and it is comes under unit 2. In mid 1 we have prepare. In mid 1 we have the exam on 2 units, 1 and 2. So here matrices and determinants lesson or chapter is also important, and we should learn, and it is an easy chapter. And every matrix has particular value, so that value is called determinant of a matrix. So here in the determinant or in the matrices, we have to know what is minor and cofactor. So how to find minor and how to find cofactor. So here we will learn determinants. So determinant means one value, a fixed value for each matrix. So in this class or in this presentation or in this period, the objectives are, on completion of this period, you would be able to know about determinants, minors and cofactors. So what is a linear equation? Linear equation is an algebraic equation. For example, ax plus by equals to 0 is a linear equation. Consider two linear equations, that is a1x plus b1y equals to 0 as a 1 and a2x plus b2y equals to 0 as equation 2. Subtracting a1 b2x plus b1 b2 equals to 0. This is come because of multiplying equation 1 by b2. A2 b1x plus b2 b1y equals to 0. Here the equation came because of multiplying equation 2 by b1. So if we subtract these two equations, we have a1 b2 minus a2 b1 of x equals to 0, because the second term or coefficient of y are same in both the equations. So when we subtract, they will get cancelled or they are vanished. So remaining is a1 b2 minus a2 b1 of x equals to 0. That implies if x goes to right side, it becomes 0 by x, that is 0. Then the remaining is a1 b2 minus a2 b1 equals to 0. The expression a1 b2 minus a2 b1 equals to 0. Here the expression a1 b2 minus a2 b1 can be represented by symbol like this. In a two parallel lines, we kept a1 b1, a2 b2. And if we did cross multiplication, like arrow marks here indicated, a1 b2 minus a2 b1. We have to keep the minus between the two products, and is called a determinant of order 2. So 2 by 2 matrix, 2 by 2 arrangement or second order matrix determinant is like this. See here, R1 means row 1 is represented by R1. Similarly, second row is represented by R2. And columns are represented by C1 and C2. So 2 rows and 2 columns are, we said, second order determinant. If it is a matrix, we say second order matrix. Here 2 parallel lines indicates the determinant symbol of the matrix. And matrix is differ from determinant because matrix is an arrangement and determinant is its value. So both are not equal, they are not same. R1 comma R2 horizontal lines called rows. C1 comma C2 vertical lines called column. If A is a square matrix, then the determinant of A is denoted by det A or determinant of A. Here we are learning if A is a square matrix, either it may be second or third order, then the determinant of A is denoted by det A, or we can symbolize like this, 2 parallel lines having A between them. It is also denoted by symbol delta. The symbol is like a triangle, but we say it is a delta or det. Determinant of a square matrix is unique. Every square matrix has a different value, so that's why we are saying it is a unique. Determinant of a square matrix. Here it is a 2 rows 2 columns, means say it is a 2 by 2 matrix determinant. So R1 has A1 B1, R2 has A2 B2. R1 means first row, R2 means second row, and C1 has A1 A2, C2 has B1 B2. C1 means first column, C2 means second column. For example, here A is 3, 4, 5, 6, and det A equals to, sometimes matrix is expressed in two parallel lines. It's a rare case, but here we have to see the difference. Matrix is kept in the generally square brackets, rarely in the two parallel lines, but whenever it comes to the determinant, det A is that means two parallel lines is generally indicated for determinant. So det A equals to AD minus BC, that is 3 into 6 minus 5 into 4. So 3 6 are 18 and 5 4s are 20. So 18 minus 20 means minus 2. So det A is minus 2, or determinant of A is minus 2. So in the short questions, there is a chance to ask the determinant of second order or third order. So the second order's determinant is, we can simply say AD minus BC. The elements of the matrix are A, B, C, D. Then that matrix determinant is AD minus BC. For example, A equal to 5 6 7 9. Then det A, here the matrix is expressed in two parallel lines, but generally we express it in square bracket. And there are three types we can express the matrix: in a square bracket, or closed brackets, or open bracket, or lines. Mostly we use square bracket, but here they use it two parallel lines. But you consider here the second step, that is det A, clearly mentioned. So determinant of A is AD minus BC. So 5 into 9 minus 7 into 6 or 6 into 7. Both are same. BC or CB same. And AD and DA are also same. So 5 9s are 45, 7 6 are 42. So 45 minus 42 gives 3, is equals to 3. So the given matrix det A is 3. Similarly, consider three linear equations, that is a1x plus b1y plus c1z equals to 0. Consider it as equation 1. Next, a2x plus b2y plus c2z equals to 0. Consider it as equation 2. Next, a3x plus b3y plus c3z equals to 0. Consider it as equation 3. Solving the 2 and 3 equations, x by b2c3 minus b3c2 equals to y by minus a2c3 minus a3c2 equals to z by a2b3 minus a3b2 equals to k. Substituting in equation 1, k into a1 of b2c3 minus b3c2 minus kb1 of a2c3 minus a3c2 plus kc1 of a2b3 minus a3b2 equals to 0. We get a1 of b2c3 minus b3c2 minus b1 of a1 a2c3 minus a3c2 plus c1 of a2b3 minus a3b2 equals to 0 is determinant of the third order and denoted by the elements we are kept into parallel lines, that is a1 b1 c1 a2 b2 c2 a3 b3 c3 in a third order determinant that equal to a1 not equal, that is a1 b1 c1 a2 b2 c2 a3 b3 c3 are called elements. a1 b2 a2 b1 b1 c2 b2 c1 are called terms in a third order determinant. Above determinant have 3 rows and 3 columns. Similarly, nth order determinants have n rows, n columns, n elements, and n factorial terms. Minor of any element in a determinant is, this means every element has a minor. A determinant obtained by deleting row and column contain it. If you want to minor of a1, then we have to delete its row and column where the a1 is intersected by row and column. You can see here the picture is shaded. So a1, b1, c1 and a1, a2, a3, these row and column are we have to delete, and remaining elements determinant is called the minor of a1. If a equals to a1, b1, c1, a2, b2, c2, a3, b3, c3, then minor of a1 equals to delta of b2, c2, b3, c3, that is b2, c3 minus b3, c2. So here you can see minor of a1 equals to delta of b2, c2. That means two parallel lines. That is the symbol. Don't confuse. Sometimes here we are using for matrix also two parallel lines, and determinant also we are using two parallel lines. But at the time of writing in our notes, for matrix we are put square brackets, and at determinant we keep two parallel lines. So minor of a1 equals to deleting its row and column where a1 intersects. You can see here by shading the part. So remaining four elements minor is here we take minor means that is determinant b2, c2, b3, c3. Then that's determinant is b2, c3 minus b3, c2. This is called minor of a1. Like this, each element have the minor. Example 1. Delta equals to 147, 258, 369. So to know the element 4 minor, that is minor of 4, we have to remove the row and column where 4 locates, or where intersect the row and column at 4. That row and column we have to remove, and remaining elements we have to find the determinant. Here, after removing row and column of where the 4 is located, then the remaining elements are 2, 8, 3, 9. So minor of 4 equals to determinant of 2, 8, 3, 9. Then we know AD minus BC, that is 2 into 9 minus 3 into 8. 18 minus 24 is minus 6. So here minor of 4 equals to minus 6. Like this we can find each element minor. Next example 2. Let the matrix is 5, 6, 7, 1, 4, 3, 8, 5, 2. Here you consider this as a matrix, and here 7 is intersected with row and column. So we are finding the element 7's minor, or minor of 7. So we are removing the row and column where intersected 7. That row and column we are deleting. Remaining 4 elements determinant. that is 1485. Minor of 7 here wrongly came, instead of 7 it is printed 3, so we have to write it as a 7. So 1485 is AD minus BC means 1 into 5 minus 4 into 8. 1 5s are 5 and 8 4s are 4 8s are 32. So 5 minus 32 is equals to minus 27. If we are any doubt or any confusion, take the calc and type, or take the calculator and type 5 minus 32 equal, then you will see minus 27. Some students do not put proper symbols or proper addition or subtraction. So if you have doubt, we allowed the calculators in the examination hall, so you can cross check and then write. Here minor of 7 we found, but in the PPT there is a little mistake. Instead of 7 it is printed 3 or it is typed 3, so you rectify this or you change this. I will change after the class. Next, summary. We discussed about linear equations, second and third order linear equations, minor of an element in the given determinant, some examples on determinant, quiz. Determinant denoted as delta, data, two parallel lines, in between them we have a, any one of the above. So here the answer is D. We already know, we learnt this class, or we saw the above slides of the presentation. The determinant can be denoted by this delta, data, or determinant of A. So all these A, B, C are can denotes for determinant. So answer is D, any one of the above. Next, if A equals to, here you think this is two parallel lines is here, it is a matrix. Question, we have to think it is a matrix. Generally it is given in the square bracket, but here parallel lines also we can take, so don't confuse. If A equals to 16, 18, 20, 30, and then data A equals to, so that means determinant of A. Here the given matrix is 2 by 2 matrix, so 2 rows, 2 columns are there. So 2 rows, 2 columns means AD minus BC, that is 16 into 30 minus 20 into 18. So 16 into 30, we have to multiply. 16 zeros are 0 and 16 threes are 48. So 480 minus 20 into 18. So 20 into 18 means 18 zeros are 0, 18 twos are 36, that is 360. 480 minus 360 equals to 120, that is 120. So determinant of A equals to, we can say 120. So here the options are given: A 80, B 90, C 120, D none. As per our calculation, we have to select C. The answer is C. So select C. So it is highlighted in different color, means our answer is right. So this type of questions also come in the examination. So we have to practice and we have to do the exercise problems. In the exercise also there are so many questions given, 2 by 2 as well as 3 by 3 matrix given. So from the textbook we can do, or we have to try to find 2 by 2 matrix determinant and 3 by 3 also. 2 by 2 we can write easily or directly, that is AD minus BC. For 3 by 3 we have to write like first element and take its minor as a product. That means product of element into its minor plus in the first row second element and its minor put together as a product and take, and next addition again plus and first row third element and its minor. So element and minor put together as a product and write. So the summation of element and its product of first row. Generally in any row or any column we can take, but if we took first row, so in the fair notes to check it is uniformity is there. However, any row or any column you take to find determinant, finally the value is same. So 2 by 2 and 3 by 3, and in earlier class, next classes also we will discuss and we will do some more problems on 3 by 3 also. Here in this class we mainly give an example for 2 by 2. In next class we will discuss 3 by 3 also. Here we learn the process of 3 by 3. determinant. So in the 3 by 3 we have 3 rows, 3 columns. So by taking any row or any column, we can write the determinant of the 3 by 3. In the first row, imagine A, B, C are the elements, then A into its minor plus B into its minor plus C into its minor is called the determinant of A into its minor, and come to the second element we have to keep minus symbol. So minus B into its minor, and again come to the third, C into its minor. So very important point is in the first row, second element contains negative symbol. Generally we told some means, but the cofactor is it's a sign into minus, then it is for second element of the first row is negative. So if ABC are elements, we have to write like this. For third order's determinant is equals to A into its minor minus B into its minor plus C into its minor. So this is for first order, using to write the determinant of first row, using first row for third order matrix determinant. For 2 by 2 it is very simple. For 3 by 3 the minor is simple, but the determinant we have to find is by any row the symbols of the elements before addition, there will be little change based on the position. If we took second row for third order matrix, first we have to take minus. Imagine in the second row we have ABC elements, then we have to start the determinant is minus A into its minor plus B into its minor minus C into its minor for second row. If we want to use second row for determinant like this, first row starts with plus and minus plus, second row minus plus minus, and third row as a first row plus minus plus. And minor, you know how to find the minor, where the element is intersected with row and column. By deleting that row and column, and remaining element's determinant is called minor of that element. We already seen in this presentation. We once again recall so that it will be in our memory. Let us recall once again what we have learned. So determinants, on completion of this period you would be able to know about determinants, minors and cofactors. What is a linear equation? Linear equation is an algebraic equation. For example, ax plus by equals to 0 is a linear equation. Consider two linear equations. a1x plus b1y equals to 0 as a 1, and a2x plus b2y equals to 0 as a 2. Subtracting. Before subtracting, we are multiplying b1 by equation 2 with equation 2 and b2 with equation 1. Then we have a1 b2x plus b1 b2y equals to 0, a2 b1x plus b2 b1y equals to 0, and subtracting a1 b2 minus a2 b1 of x equals to 0. That implies a1 b2 minus a2 b1 equals to 0. The expression a1 b2 minus a2 b1 equals to 0. The expression a1 b2 minus a2 b1 can be represented by symbol and is called a determinant of order 2. So R1 and R2 represents as a first row and second row, that is horizontal lines called rows, and C1 C2 vertical lines called columns. If A is a square matrix, then the determinant of A is denoted by det A or det A. It is also denoted by the symbol delta, or we say det. Determinant of a square matrix is unique. Determinant of a square matrix. For example, A equals to 3, 4, 5, 6. Det A equals to 3 into 6 minus 5 into 4. That equals to 18 minus 20 equals to minus 2. For example, A equals to 5, 6, 7, 9. Det A equals to 5 into 9 minus 7 into 6. 45 minus 42 equals to 3. Similarly, consider three linear equations. a1x plus b1y plus c1z equals to 0. a2x plus b2y plus c2z equals to 0. a3x plus b3y plus c3z equals to 0. Solving the 2 and 3 equations, x by b2c3 minus b3c2 equals to y by minus a2c3 minus a3c2 equals to z by a2b3 minus a3b2 equals to k. Substituting in equation 1, we get k into a1 b2c3 minus b2c2 minus k into b1 a2c3 minus a3c2 plus k into c1 a2b3 minus a3b2 equals to 0. We get, after taking k as a common and if we took right side, 0 by k is a 0. That is determinant of the third order and is denoted by a1, b1, c1, a2, b2, c2, a3, b3, c3. So here is a third order determinant, and the a1, b1 are called elements, a1, b2, comma, a2, b1, comma, b1, c2 are called terms. Like this, we can say minor and determinant. These are all discussed. You can see the presentations, and I will post in the WhatsApp group also. And if you have any doubts, you can ask me so that you can clear your doubts. You can ask me on WhatsApp also, message me and do the homework. Thank you.